Are you ready for sustainable tire production? Difficult times require an analysis of processes and consequently a development of new strategies, so you can get back into action. HF, sent for future demands in tire production. Join us for iTech 2020 Virtual Edition on September 10th, 12 p.m.
Welcome to iTech 2020. I'm Larry Evans, and it's my privilege to introduce our next speaker, Manuel Bessler. Manuel is the General Sales and Project Manager for UTH Germany. UTH is a fine example of German technology specializing in gear pump technology and fine straining applications. Manuel completed his industrial engineering degree from Ilmenau University in Germany. He then joined UTH and has since has been totally committed to the development of cutting-edge solutions. As an example, in the field, he will take you through the financial and environmental advantages of reworking unvulcanized rubber produced in tire production, and present technical solutions which support your goal to become more sustainable while reducing cost. Over to you, Manuel.
Yeah, thank you, Larry, for handing over the word to me. Welcome to today's digital presentation. My name is Manuel Bessler. As Larry said, I'm responsible for the general sales and project management in company UTH. Today's topic for the iTech 2020 tire manufacturing will be new technology for efficiency and material saving in the tire production. Company UTH. UTH was founded in 1985. Basically, we started with the overhauling of second-hand machines before we entered into the field of gear pump, especially fine mesh straining applications in the 90s. The main location is in Fulda, which is close to Frankfurt, Germany. And here we have our headquarters with technical center. Today, we have international subsidiaries, representatives, and partners all around the world. We can offer a global service and sales network. Today, I brought to you the following topic. The agenda is, as first, the tire industry applications of our Rolex gear pump technology, especially in point 2, the TRP technology, the basic principles. Out of the TRP principle was established the TRP reworker system 2800 with integrated gear pump. As point 4, I will show you a benchmark between the TRP reworker system 2800 compared with a mixing line. And as last point and finishing point, a conclusion and a summary. Within the tire applications, we have different applications and solutions realized. We are working in the field of straining of master batch within the mixing line with a direct sheet forming. We are working in the straining of final compound rubber within the mixing line or in an offline application. We are working in sulfur chemical batch straining within the mixing line. We can offer to you the straining of inner liner within the extrusion line or within the calendering line. Beside the straining applications, we have extrusion applications such as precise or high pressure extrusions. The rework and reprocessing, we have, let's say, started also with the straining of the rework material within a conventional rework line and realized a big demand for an automated, safe reworking system, which leads us to our topic from today, the TRP reworker system. The principles of rework processing and its requirements. For sure, you know, during the startup and ramping up of the extrusion lines, you will generate rubber of various types and shapes, such as sheets, blades, or shaped profiles, which are not in the right specifications. Till the extrusion is stable, you will produce some rubber compound, which is too valuable to scrap it, and you need to rework it. The reworking needs to be in a gentle way, but at the same time, you need a sufficient plasticizing and a good homogenization of the rubber compound. Especially the thread compounds are more than only one rubber compound. So at the end, you want to have one homogeneous mass, and in the beginning you have maybe 3 or 4 different compounds within one piece of rubber. For us, it was very important to have an encapsulated processing area to keep the safety standards high for the operator. Further, we wanted to achieve a good access to the processing area, because from time to time you will have the cleaning and the material change. Further, and this is the most interesting point, you can achieve reproducible and automated processing with a minimum of manual intervention and less demand of staff. So all what you do is not the skill and the knowledge from a worker, it's the skill and the knowledge from a recipe within the machine. Optional, you can have and add a fine mesh straining of the material with a subsequent extrusion of sheets or straps. The TRP technology and the basic principles. I will show you the crossover of proven process techniques, the principle of the TRP technology, the variable parameters to optimize your process, and a typical material temperature profile along the rolls. The crossover of proven process techniques. It's an innovative process for particularly gentle and a continuous processing of rubber compounds. The TRP technology is based on an open roll system with different zones along the rolls. Here on the outside, you can see basically a blue marked line. What we did for the TRP, so two-roll process, we combined different available rubber processing technologies in one system. So we have a feeding area, a feeding zone, which is typically the role and the job of cracking the material. We have a homogenization zone to homogeneous and to plasticize the material. We have a forwarding of material along the rolls, which we call an extrusion or forwarding. And we have a discharging zone at the end of the rolls. When I say a pair of rolls, we will not have only one roll, we will have two rolls. So we have a sheet roll and we have a counter roll. We have a feeding zone where we enter the material. We have a plasticizing and a homogenization zone to have a suitable and a good plasticizing of the compound. And we have a discharging and shaping zone. When the material is entering, it will be in the nib of the two rolls homogenization and plasticized. Till the end of the two rolls, there's the exit and the discharging zone. On this slide, you can see basically the principal design, what we just went through. But you have different compounds. So we have also foreseen different parameters which you can set to adjust on your compound. As first, you can adjust the speed. So on the roll itself, you can have different speeds available. Each roll has its own engine. This means we can also set a friction between the two rolls, between the sheet roll and between the counter roll. We have different temperatures along the rolls, so we can have a different temperature on the sheet roll and on the counter roll, but we can also have a different temperature in the end of the rolls. So you can have different temperature profiles along the rolls. And as last, this conditionally as a presetting, the nib, so to say, between the two rolls, between the feeding side and the discharging side, you can have a certain angle in between for adjusting on your compound. What you can see here is basically a typical temperature profile. So the material is entering the machine with about room temperature, maybe 20 degrees. The material temperature will go up in the first step quite fast, especially in the cracking zone. So the material, bypassing the nib, is fastly rising the temperature until a certain level. With the help of the other machine components, by passing the first time the nib, the material will go down, and by some special conveying system, the material come up and will be transported in the homogenization zone. This means here in this area between the nib, the material temperature will reach its target or its maximum temperature in this process before we have the possibility to cool down the material at the end of the rolls. So in this zone, you can set a lower temperature than on the beginning and in the feeding zone. This is needed because by adjusting and adding a gear pump with straining head to filter and fine mesh strain the compound, we will add some temperature within the compound temperature. And by reducing the temperature first, we have some range to go up in the temperature profile. This whole process from feeding the material, the homogenization, plasticizing, discharging, and straining is around 90 to 100 degrees. So you have a very good control over the material temperature. The TRP reworker system. It was established out of the TRP process. This means as first we put it in a 3D design. We have a production size generated with options, and as a third I will show you the reworker system, how it is nowadays in the market, established, the system layout, to get a good understanding how the whole process is working. The 3D system. basically we start with the feeding of the material. So we have a feeding conveyor. The material is going up into the feed hopper. And underneath the feed hopper, the feed section of the TRP rolls is where the cracking of the material is happening. On the left, you see the drive of one roll, the hopper. You see here on this side, on the left side, from the encapsulated area, one roll. So this whole TRP process, the two-roll plasticizer process, is within the encapsulated area, and it is safe. So there is no possibility to have any contact in the production process. You see the rolls, you have a control panel later for the cleaning or any maintenance operation. You have the second drive, and here underneath you can imagine the discharging of the compound. But this whole process you will understand in the next slides a bit better. The first TRP 2800 was and is equipped still with a feeding conveyor. We have an inclined conveyor with a metal detector for transporting the material to the feed hopper. By entering the feed hopper, the material gets cracked and gets plasticized in the nip between the two rolls. In this application from the feeding, it doesn't matter which shape the material is looking. This can be thread pieces, this can be larger thread pieces, this can be lumps, different shapes. As a second alternative, you can also feed the machine with a slab feeder. So it might be that you have material which is rejected from the quality department, which is a bit out of spec, and you can use the machine for reworking, viscosity change, for example. Or what you else can do is the blending of material. So you can take fresh virgin compound, adding with some already used unvulcanized thread compound. By exiting the machine, you have the choice of the straining and the sheet extrusion, or just the shaping in form of a strip. This is basically a general overview about the TRP 2800. So on our end is basically the scope. We start with a lifting table for your compound, for the thread compound, for the apex, for the sidewall, doesn't matter, for a good economical. You have the loading conveyor. You have in the front the control panel from where you can control the full process. So you have screens like a typical HMI, but you have also screens to supervise the process with a camera system on the TRP process and on the feeding. From the loading conveyor, the material is entering the weighing conveyor, in which the piece weight will be measured, as well the height and the length of the material. So the machine recognizes for you, okay, I have now a thread piece of 25 kilograms, and I give the setting according to my knowledge, what I gained. I want to have maybe 10 kilogram pieces. Then the machine will make 3 cuts. It will have a first cut after a certain amount, a second cut, and a third cut for a smaller piece of the 25 kilograms. This is based on a cross cutter, on a safe cross cutter guillotine system, our own UTH development for this special application of cutting thread compounds. The material is going up with the feeding conveyor, bypassing a metal detector into the hopper. Beside this, you have, as already mentioned, the possibility to feed slab material, to blend it, or to take 1 or 2 or up to 3 pellets slab material with a maximum of 36 millimeters. By the TRP process, underneath the gear pump is installed with the strainer head and we extrude the material in shape of a sheet, like 800 millimeters width or 1000 millimeters width. The machine comes with a hydraulic system and TCUs to adjust on the different compounds and to have a good material temperature. This is basically the scheme of a cooling area, for example, a batch off. Here we work with different batch of suppliers on a good interface that both machines work together as one unit. The comparison between a TRP system versus a mixing line. This is just a really rough indication for you to understand what space is needed for the line. So here basically the TRP line needs a space with some loading space for transporting the material for rework compound and for already reworked compound. You can calculate roughly 4,000 cubic meters. The batch off would be here on this side as well, and you can understand the needed space. One way of the reworking of compound is to do the reworking via a mixing line. For a mixing line, basically you will have, for this capacity throughput, we have chosen a 270 liter mixing line with 3 mills and a batch off. The mixing line, as you know, has most cases a second or even third platform for the conveying and also for the material supplying and different site equipment. A rough value can be seen as 16,000 cubic meters space. To give you some data, the batch weight of a 270 liter mixer's rework compound is approximately 240 kilograms. The mixing time per batch is around 2 to 3 minutes. At the TRP 2800, you have a continuous process. The output per hour for the mixing line is around 16 batches. The output of a TRP 2800 is around 2.5 tons per hour. The challenge is for the mixing line to load the conveyor, because as you know, the rework compound, all the pieces needs to be dropped on the conveyor, and this, when the mixing is finished after 2 to 3 minutes, the next portion needs to be ready. The straining of rework, it can be installed, a strainer within the mixing line, but it's in, let's say, in most cases, in additional step that the customers have somewhere in offline straining. So there is an additional step required. It's an advantage on our end. The cutting of the material needs to be, in terms of loading, done manual. In our case of the TRP 2800, it's an automatic cutting by the cross cutter. The residence time of the rubber compound on the mills and in the mixer is about 9 minutes. It's quite a long time compared to the continuous process when you look at the TRP. It's a batch versus a continuous operation. Looking in a very interesting point, the energy. The whole TRP 2800 with its conveyors, slab feeders and roll engines as well as gear pump engines has an installed power of roughly 500 kilowatts. When I look on the mixing line, 270 liters with at least 2 or 3 mills, we will be at the installed power of maybe 1,500 kilograms. So 3 times this value. This means, of course, the specific energy, what is needed per kilogram, is much more less with the TRP 2800 compared with the mixing line. So you have a much energy saving when you calculate on each kilogram rework. The safety issue on the open mills you are familiar with, so it's a dangerous workplace. For the TRP, we have an encapsulated system. The process temperature in the mixing line and open mills is around 120 to 125 degrees. For the TRP, we are somehow around 90 degrees without straining, around 100 degrees at the production capacity with straining. So the TRP process is a very gentle, material gentle process. The labor, the assumption of a line, we put here like 3 workers. For the TRP line, you can run the line with 2 workers, 1 operator responsible for the process and a second person as a worker for loading the material. Straining, when you do it after the mixing line, requires extra labor time and costs. A metal detector, in our case, it's included. To give you a rough indication of a pricing, the total investment of a mixing line, we assumed and calculated roughly 5.9 million, including a strainer. For the TRP, 2,800, we can give you a number of 2.9 million euros, including a batch off. This is the batch off assumption price. Typically, you as a customer have your own batch of supplier and requirements, but to give you a rough pricing for the total investment of this system. Coming to the summary and the conclusion of my presentation, the TRP reworker can give you up to 50% energy savings compared to existing technical processes. It's very environment friendly, it's very good temperature control, and which leads to a good quality. It's an encapsulated system for a high degree of safety. About 5% of the raw materials can be saved, and up to 98% of the waste can be reprocessed of the compound. It's a compact solution, space-saving design for keeping the costs under control. The modular design provides you different applications and customized designs. So we are flexible in terms of conveying the system and guiding the system according to your demands. You can achieve reproducible results, which is, I would say, a very interesting point for the quality, for having a long stability and high-class product. And you have optional the possibility of fine mesh straining. With this, I'm on my end with the presentation. Thank you for participating on the virtual ITEC 2020. I hope my presentation and explanation to our TRP reworker system 2800 was interesting, and I'm looking forward to receive further questions, comments from your end. Thank you. It was a pleasure to be here. Goodbye.
I want to thank Manuel for an interesting and valuable presentation. I want to thank you for joining us at ITEC 2020. And of course, I want to thank our sponsors.